Hey, it's your tutor Courtney Waterman, lover of anime, manga, and math. And this is another session of Tutor Me Senpai. Welcome back, everyone. I'm Courtney, and this is another session of Tutor Me Senpai. Today, we're going to be going through some 11th grade matrix multiplication, but more specifically, dealing with vectors. So you can say vector multiplication. If you've already seen my last video on matrix multiplication, this will be very similar, except we're going to be focusing on vectors. If you're unsure what a vector is, it's pretty much either a column from a matrix or a row from a matrix. So it doesn't have the full body that a matrix would normally have. It's going to be a one column and many rows matrix or a one row and many columns matrix. But you'll see that as soon as we dive into our question today. So our question today says we have a vector of 6, -3 multiplied by another vector of -5, 4. So the last video I made on matrix multiplication told us that we had to be aware of the sizes of our matrices. Now vectors, like I said, are just like matrices, but as you see, this one only has one column. Although it has 2 rows, it only has one column. While this one has 2 columns, but only 1 row. So vectors, like I said, are either going to be a row from a matrix or a column from a matrix. Everything else still pretty much applies when you're doing the multiplication. So we're going to have to figure out what is the size of this. So we said this has 2 rows and it has 1 column. This has 1 row and it has 2 columns. Right? 1 row, 2 columns. 2 rows, 1 column. And like my previous video where I told you about making sure you have the sizes of your matrices down, we can see that these are compatible. If you haven't seen my first video, I recommend you do that because we go over the compatibility and the reason why we do this a little bit more in depth. But we see they're compatible. And we also see that our end result is going to be a 2x2 matrix. We can start building this as we expected. So we're going to tackle this like I did in my first video by putting a big matrix here and adding this extra notation just for the video. This is not proper matrix notation, so don't put that on any final homework or tests or anything. This is purely to set up so we can go step by step and you can see where things are supposed to end up. Okay? So once again, we should get a 2x2 matrix, 2 rows and 2 columns at the end of our vector multiplication. Okay? So just like matrix multiplication, our first matrix, in this case our first vector, we go across, and our second matrix, or in this case our second vector, we go down. Okay? But this will be a little bit easier. As you see, we only got to go across 1 and down 1, right? So when we take this first number in our row, we multiply by the first number in our column. So 6 is going to be multiplied by a -5. And there's nothing else. So this is going to be our first position of our 2x2 matrix. So let's keep going on this column and let's figure out what our second position is going to be. So when we go across, we still have this -3 here, multiplied by our same -5 because this is still looking at that first column. So we have -3 multiplied by -5. Let's look at our third position. We're still looking at our first row, but instead of looking at -5 here, we're going to shift because we're looking at this second column here. We're going to look at the second column of our matrix here. So we're going to be looking at 6 times our 4 instead of our 6 times our negative 5 like we did here. So 6 times 4 is going to go here. All right? And do the same thing for our 4th position. We're going to shift down to our 2nd row and still focus on this column, which is only the 4. So we're going to get negative 3 times 4. So now we filled in all the positions of our 2 by 2 matrix. Let's simplify them to get just numbers because we don't want all of this in our final answer. So when we look at 6 times negative 5, what do we get? We get a negative 30. So we can erase this. All right, when we look at negative 3 times negative 5, what do we get? We get a positive 15. So we can erase this. When we look at 6 times 4, what do we get? We get a positive 24. So we can erase this. And when we look at negative 3, can we see that there? Negative 3 times 4, we get a negative 12. So we can erase that. So our 2 by 2 matrix says we have negative 30, 24, 15, negative 12. So once again, this is not proper notation for a matrix, so let's get rid of it. All right, so now we have our matrix, which is 2 by 2. We have 2 columns here. We have 2 rows here. So 2 rows by 2 columns because it's a 2 by 2 matrix. Although we started with vectors, and remember, this was a 2 by 1, and this is a 1 by 2. By multiplying, we actually got a 2 by 2 matrix. Let's see if any of these match up with any of the answers that are on our question. When we look back at that, we see that this answer is B. So B is our answer. B is negative 30, 15, 24, and negative 12, just like we got here. Once again, I want to warn you that you need to know the sizes of your matrices, not just for compatibility's sake, but also because unlike scalar multiplication, matrix A times matrix B doesn't always equal matrix B times matrix A. And if you look at it, you can see why. This 2 by 1 and 1 by 2 tells us this is compatible and we're going to get a 2 by 2 matrix. So if we multiply it this way, we get a 2 by 2 matrix. But what happens if we were to shift this? Well, then we will have a 1 by 2 matrix times a 2 by 1 matrix. And yes, these are compatible, but now you end up with what? A 1 by 1 matrix. There's only one number in there. So we went from having a 2 by 2 matrix, multiplying it one way, to getting a 1 by 1 matrix, multiplying it the other way. So you need to make sure that you know the sizes because order matters when you're talking about matrix multiplication. So that concludes another session of Tutor Me Senpai. Today we went through 11th grade matrix multiplication, but we focused on vector multiplication this time. Because vectors, just like regular matrices, have the same type of multiplication that's happening, but it's a little simpler because vectors are pretty much just either a row or a column from a matrix. But once again, once you have them set up, you need to know what their sizes are because depending on how you combine them together, you could get vastly different results. So if you haven't seen my first video on matrix multiplication, I challenge you to go back and watch that one because it might do a little bit better job at filling in some blanks when it comes to matrix multiplication. If you enjoyed this video, I challenge you to watch it again and again and again and again. Math needs practice, and I can't say that enough. So keep practicing and keep working hard and don't get discouraged. If you found this video helpful, leave me a like. Drop a comment in the comment box. Hit that notification bell so you know when I do any more videos like this. And also hit that subscribe button so you can also stay up with me as I'm dropping more content each and every week. I hope this video helps with your homework or anything else that you're currently working on, and I really do hope to see you next time. I'm Courtney, and this is another session of Tutor Me Sempai.